normal blades. Normal blades you've got to carve. It's almost like balancing a tyre. You've got to get it to function right, and you can't little bits away and do that. So that's how that works in that respect. This is an example of a completely everything you see there was completely 3D printed and then milled away. And this is a complete jet engine that Aerospace did to test the fact, can we run a jet engine? Will it work? Will it hold together? There's a lot of studies in how metal powders bind together when the laser's into, how strong they are. Are they better than welds? Are they better than cast or better than foam material? So lots and lots of work going in this field, and you're going to see much, much more in this. Custom engines, custom pistons, very unique systems that you can't physically make any other way, but you can 3D print them. So certainly a lot more of that. Big printers, I saw some 4 foot by 4 foot printers at the shows, and they're able to print architectural models. Again, because of the geometry, you can have all the interior detail very easily printed and showcased. And certainly, I've done some stuff for FIT. We printed some 3D models and put in a whole showcase together for things. So we've been doing that all summer for them. These are 3D printed concrete buildings. This was a castle that somebody wanted for his daughter in his backyard. This was printed in China as a relief type building, so they can print 20 of these a day with the one system that they've got, literally 24 hours for printing that. It's about a 10 by 10 unit with a glass wall on. They literally 3D print it. You go into any war-torn disasters, things like that, you can print solid structural things very, very quickly, very efficiently. It literally is just a crane with a big 3D print concrete head on it, is how it actually works. Biometric and food industry. So food industry is very much, these are sugar. So that's then ready to send and print. Now, component parts on the printer, obviously, mine's slightly different. I've got what we call lead screws. Now, you'll typically see lead screws on the end pieces that lift it up and down, but normally on the X and Y, you will have a belt-driven system. A lot of people like belts, and they like linear rails, which are just steel rails with bearings on them. I prefer to use linear rail wheels, any kind of a wheel bit, because basically what you're trying to do, you're trying to keep that print head within a fraction of a millimetre wide. So you don't want it to vibrate out or move out. So by having linear rails, it keeps it on a locked-in system forwards and backwards. And then the lead screw stops what they call backlash. So imagine taking that 2-pound head or 1-pound head and throwing it along a linear rail, and then you've got to go. So it's printing basically what I've told it to do. And one of the things you do when you've got ABS and things like that, you push out like a perimeter. It's just a single layer that goes out from the part, and it keeps it held to the bottom, stops it lifting and walking. And that's what I'm doing here, is creating a border for it to push out to.
Right now it's only using one head, right?
This is a single head I'm running. It's got 2 heads, but I'm on another one.